Good morning. Good morning, everybody. Namaskar. This is Suraj Singh speaking from Bharat, India on this day, March 5th, 2022, Saturday, and this is 3:50 a.m. नमस्कार, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक मार्च 5, 2022, शनिवार 3:51 सुबह के। एंड टाइटल बिफोर यू सही मैसेज वो लिटिल चेंज quality coordination engineering both are combined in project works communication concrete civil engineering reliable engineers etc our context SHG designs and construction methods claims organizations. Talk is as usual with of course certain additions. Email ID is suraj_engineer at yahoo.co.uk. Suraj is suraj underscore engineer ENGINE here at yahoo.co.uk. This person is Chartered Engineer India, who is IM and International Professional Engineer India. And this is your Chartered Engineer India certificate. And also we can say here is Chartered Engineer certificate, and also here is Professional Engineer certificate as well. Professional Engineer certificate that's opening, and you can say it is now here. It should not placed before. Now I placed it in. This is Professional Engineer certificate at international level, INTP India, and of course this is Fellow certificate, and this is quality file as well as coordination file. This fellow member I close, and C I close, just for information it was. And now this is certificate, and these files I'm going to discuss with you. These are coordination engineering files. This is international engineering files, and of course I would say quality coordination engineering, as well as I would say quality file. I think I missed somewhere. Let me reopen it. Quality file, and that's this one. This is quality file, coordination file. These are discussable files in this talk as usual. And coordination engineering, if you think such projects, I have played only few projects out of my experience like this. I can show you these projects. And there are so many other projects I'm not including, but only this I don't have records of this. I mean, don't have any photograph. You can look at them. I could get this photograph from you can say Google Earth. This I could get. I don't have it. This is a school built in 1986-87, located at Amsalal in Qatar, Doha, on Al Khor Road. And if you come 8 kilometers away from Grafa roundabout, on left, this is located. And also this is in this project is Dar Al Thawra. You can say this project is Dar Al Thawra Press Complex. This is located in Baghdad, near, just adjacent to, in left side of this is Conference Palace. And this is the center of city. You can say it's very important. It was very important because I was there in 1982 with Eurolec and Associates. And just for information, I'll be responsible for tower portion of this building. You can see this is tower portion, and this is only up to few floors. Here this is terrace of few floors, and this is tower portion here, and many other buildings. There are so many other buildings at that time. I don't know what's happened now. It's long story, back story. And then it's a plant, ethylene plant, located Troyes industrial area in Abu Dhabi. You can say at least 300 kilometers from city Abu Dhabi, where I was at least for 3 years, so around 3 years on this plant as a technical person, or you can say office engineer, involving with many issues. I'll explain that one. This is a process plan. Yesterday I downloaded from this site. This site you can say research.net application. This research.net figures schematic view of an ethylene plant based on steam cracking. And here is what circuit is, and we'd like to have a look on this, just to let you understand what actually I'm talking about. I'm not expert of this, but yes, only a plan just to explain where I was on this, what I did on this. And then if you go further, this is one element of that project. and this also located in Qatar. This is firing range, shooting range. This shooting range here, and this shooting range, and this is firing range, 330 meters long, and this is one of 4 elements or 5 elements on that project that we had on behalf of Alatia Contracting and Trading Company. I was the site agent or project agent of this project. This is one part of that on which we had some problem. Also, I'll discuss was that this was also in 1987, 88, 89, 1987, 89, and this was the 2nd Royal Guard Army camp here. This was called Barjan Army Camp, 2nd Royal Guard located in Barjan, which was on Al Dukhan Road. If you start from Doha and go to Dukhan Road, you shall find that this camp is located about 8 kilometers from that roundabout to the graph roundabout, and we can say that this is here. Layout of that also downloaded it from Google, as far as it is also downloaded from Google, but I don't have it because it's an army project and we are not allowed to photograph. And this also we had ethylene cracking plant. It was all same as I discussed before. For a second of that, and that's here was involved for 2000, 2001, 2002, and same way I can say. I'm just briefing. It's a seawater basin, which is part of the plant, just part of the plant. And here is also this is a record house, digital record house located in Masaid, Doha, and this was built for Qatar Petroleum in 2003, 2004 I hope, yes, 2003 and 4. It's a small project but very important one, and this is also taken down from, downloaded from Google Earth, from Google Earth itself. I don't have any record of these projects, but this is photograph was given to me by someone. I was there on this hospital project in Jeddah, which is known as clinic, and this was about this was 2010. I was there as project manager. This structure was already built, and I was just to help us. There was some problem, and this too much delayed. I was 75th engineer, I hope, on this project. And this is also I downloaded from Google, not from Google, from downloaded, and you can say a pictorial view of this school, this hospital, and this is pictorial view, not exactly one, and this is I think from records, and you can say also this is LNG tank project located in Ras Laffan industrial area in Qatar, 80 kilometers from Doha, and this is if you go down there. Al Coral Gate reached there, and Ras Laffan was there for 1 year in 1996. 1996. I'm sorry, 1996. I was responsible for records of surveys for these four tanks, LNG tanks, these LNG tanks, and also there was one project. It's not shown here. It's a beach villa project, about 10 kilometers away from this beach villa on near sea or other side. I was responsible for coordination of that project, and of course not many projects are not included. This is not CV actually. This is just important because I can discuss as part of coordination on this talk, and this also downloaded from internet. And this is actual tank, you can see, and this is another view of this tank. These 4 tanks, you can see that one. And it's internal work of the science. It's a given actually. It was photographed in that time. You can see internal work of this internal tank is ongoing, and you can see actually this also a real view of that project which was constructed, and you can see this was I brought as many pictorial views as possible so that you can at least discuss. And this is also a part of that plant, as I discussed in always. This is the administration building area, and this is amenities building, as well as there are some other facilities there. There is a workshop area. Likewise, house and maybe some other issues. I exactly know say. And this is a part of that plant, cracking unit, cracking furnaces, And here is also same continuation of structural steel arrangements on that industrial unit, ethylene structure, and also here is, you can say, this is a house, you can say this non-industrial projects, residential projects located in Faridabad, and this is a structural arrangement of that very small house, not very big, but I have to discuss coordination issues. We can say here, that we have to go and move on that, and this is some plan of that house. I will discuss how to do communication. These are all required, and that's the view here. And this is a file that shows this, and I also have the file. I hope I will be able to share with you. I did not open it yet. And this is constructability development. I don't know what's that actually. Let me see. Constructability overview. Yes, only buildability. No, I don't know what's that. Just make this constructability development. Let me see which one it comes. Maybe it's the same one. I think it's not. It's not same. I've discussed this before also. Just not this file. Let me see if I open my file. I like this important file. I downloaded it yesterday, and that's what I say. It's very important one for everybody, and we can move on that. Let us see how it works. It's actually very important file, a long one of course, but it's good if you can move that one away. You can move with that, we can say. Let me see if I file, I can open it now for you. And that is constructability and overview, science direct topics. So start, let me see. No, not this one. Not this one also. Clickable engineering, buildability, construction, designing, or that. 9. Next generation steam cracking, I think, is that. Yes, it is that. Next generation steam cracking plant. This is a good one. Let me open this file as well, and you can see it's a big file, of course, but this is good for us to see how it moves. And let me blunt down this little. And that is of course not my downloaded, and it's about propylene ethylene. And the propylene ethylene, this is author is Markov and Technip EFMC Technip. Okay, so this is propylene ethylene and C2H6, you know that C2H6 goes to C2H4 and H2 hydrogen separated. So C2H6 goes to C2H4 and H2. The next generation steam cracking reactor concept, it is next generation steam contract, next generation steam cracking reactor concept, Markov and Geotherm. And this is what we have here in store for you, next generation steam cracking reactor concept. And so it is just for sharing and understanding at least something. And something was prefaced. This work in front of you was initiated in the year 1998. This year I received my Master of Science degree, which is most logical, so that is another one. Let us go to summary. Next generation steam cracking reactor concept, and that's what is important here to understand. Steam cracking process is an important asset in hydrocarbon processing industry, and we are talking of hydrocarbons. Steam cracking process is an important asset in hydrocarbon processing industry. Main products are lower olefins, ethylene, propylene, butylene. Lower olefins, ethylene, propylene, butylene, and hydrogen, with ethylene being the world's largest volume organic chemical. Ethylene, world's largest volume organic chemical, at a worldwide capacity of 120 million tons per year. Now, feedstocks are hydrocarbons C2 plus. Feedstocks such as feedstock, we are talking of ethane, LPG, naphtha gas, condensates, and gas oil. These are feedstocks. Ethane, LPG, naphthas, gas condensates, and gas oil. I'm just giving a brief background of what we are talking in coordination. Olefins yield is predominantly determined by steam cracking furnaces. Olefins yield is predominantly determined by steam cracking furnaces. These are retrofits of common heating furnaces. Retrofits of common heating furnaces made capable of adding a large energy flux at high temperature levels to drive endothermal cracking reactions. Evolutionary design has led to current state of art cracking furnaces. Steam cracking technology has developed steam cracking technology has developed from an empirical approach to a design and operations to a deep model based understanding. Models can predict what is happening in cracking coils and resulting olefin yields given feed conditions, coil configuration, and incoming heat fluxes. Due to extensive optimization of design and operation, current steam cracking has become mature, yet a clear insight is lacking how far current olefin yields are removed from theoretical maximum according to fundamental mechanisms. Finding a significant potential for yield improvement would justify a step out in cracking reactor technology. Identifying such a potential is main driver for this thesis research. Approach taken is to explore and exploit fundamental opportunities chemistry offers instead of taking more restrictive view of what current equipment is capable of or limiting to. Research goal is to search for intrinsic optimal steam cracking reaction conditions, pushing olefin yields to maximum that fundamental reaction kinetic models allow for. Such optimal conditions can serve as targets for developing a next generation steam cracking reactor. Search is based on mathematical modeling and optimization needed prior to expensive experimental validation to get what we have. So this is procedure that's not well going. And this is we have to go through all this and here is summary, you can say prefaces, summary, research objectives and approach. Then current steam cracking technology we have to know better. It is as ideal reactor concept for ethylene from hydrocarbons, and it enhancing Spiro with a symbolic modeling facility towards synthesis of optimal steam cracking reactor, thermophysical optimization for high olefin yield, conclusion and recommendations, and symbolic, all these are by, so that's all I can find. Research objection of what's ethylene is what's largest organic petrochemical. That says ethylene is what's largest organic petrochemical due to its application as raw material. Thus ethylene is world's largest organic petrochemical due to its application as raw material for intermediate base chemicals such as polyethylene, ethylene oxide, and styrene. So you know this polyethylene, ethylene oxide, and styrene, all we know in civil engineering, styrene, polyethylene, ethylene oxide. These chemicals, base chemicals, are applied in innumerable consumer products. Approximately 60% of all ethylene demand is required for production of polyethylene. Good night at all. Okay. Primary use of polyethylene is in plastic films for packaging and all kinds of bags. Ethylene oxide is a raw material manufacturing of polyesters, In manufacturing of polyester, the ethylene oxide is a raw material in manufacturing of polyesters, ethylene glycols, surfactants, and detergents. Styrene monomer is used mainly in polystyrene for packaging and insulation. We use insulation polystyrene in our buildings, you can say in cavity walls. We use on roofs itself polystyrene, polystyrene for purpose of insulation, as well as in styrene butadiene rubber. Uses of consumer products is typical for prosperous societies, and therefore demand to ethylene is an indicator for prosperity. So ethylene, and this ethylene, I worked on this plant which was named as, say, ethylene cracking plant is ethylene, and you can say I don't know exactly 600 kD ethylene plant to plus. Production of ethylene has been dominated by steam cracking process. Steam cracking is boilers, etc. Production of ethylene has been dominated by steam cracking process since World War II. End of World War II, you can say, with a worldwide production of 128 million tons ethylene per year. This is 2009 position. Propylene is main side product. As main side product, 48 million tons is often used as swing to balance profitability. Feedstock for steam cracking is hydrocarbon C2+, such as ethane. These are feedstocks for steam cracking, as all this is. You can say ethane, liquefied petrogas, LPG call it. So feedstocks for steam cracking hydrocarbons, such as hydrocarbons which are ethane, liquefied petroleum gas, LPG we generally call it propane, you can say, naphtha, gas condensate, and gas oil. Continuous research and development efforts are performed to achieve better ethylene yield and lower energy consumption. In addition, use of alternative feedstocks such as biomass, natural gas, synthetic feedstocks from Fischer-Tropsch methanol and ethanol has also been pursued. In next section, we'll highlight limitations of existing process structure, both conversions by steam cracking and product separation, which is described in more details. Okay, focus on chemical conversion step, which is the steam cracking fundamentals, you can say. Limitations of existing stockroom technological limitations. I'll see a little one on this, just a few lines. Current steam cracking technology has reached a stage of maturity in which improvements in yield and product selectivity are becoming increasingly difficult due to engineering restrictions. Heart of cracking technology is to highly heat integrated furnace with cracking coils suspended vertically in radiant box through which hydrocarbons feed diluted steam flows. Hydrocarbons are being cracked at temperature level above 600 degrees Celsius at a low pressure 1.5 bar within a short residence time, that is less than 1 second. Due to high reaction temperature, feed is preheated in convection section of furnace. Highly endothermic cracking reactions are being driven by incoming high radiant heat flux, that is 95 kW meter power minus 2, towards cracking coil at a temperature level of correspondence 1050 degrees external to coil. Radiant heat flux is generally by combustion of fuel, mainly methane, at temperature level of 1250 degrees Celsius, that is methane. Radiant heat flux is generated. Radiant coil effluent is rapidly quenched, temperature corresponding 600 degrees Celsius, to preserve composition to capture thermal energy by production of heat, pressure, steam. Energy efficiency, fraction of fuel combustion energy use of furnace is achieved by heat integration, and steam production is in order of 90 to 94%. Typically, ethylene yields are improved by raising cracking temperature and reducing residence time. Increase in cracking temperature is obtained by increasing firing duty inside firebox, through which temperature of cracking coil increases. Currently, metallurgy of cracking coil is a limiting factor, since Cr and I chrome nickel alloys used to have a maximum allowed These are contents in this book, and you can see this technical innovation options for ethylene production. And this is here, and context and scope of research option. This is a very, very technical book, and we'll see into this. And this is also a circuit, so kind of conceptual activities in development and designs of chemical production processes. And also we can say this is phenomenon relevant for steam cracking process. So various technical details, research approach. So just for information, I'm telling you, but we will take time in this some time, and not exactly means some, just to have a knowledge of steam, location of steam cracking supply chain, where it is. And that also you can say here is schematic overview of petrochemical industry. You know, what is that? You see, feeds, intermediaries. Let's say it's crude oil. It's, for example, it's natural gas. As crude oil comes, you can say crude oil that goes to refinery, right? Crude oil goes to refinery. Let me break it down a little so you can see clearly. Crude oil goes to refinery, and the refinery goes to steam cracker. First refinery works, which is a big one. Refinery itself is a big technology, a very, very vast technology, and refinery goes to products also. For example, refinery goes to plastics, it goes to fuels, solvents, elastomers, fibers, detergents, foams, lubricants, asphalts, anodes, resins, fertilizers, others. So it also goes to steam cracker. And there's a natural gas which goes to steam cracker. There's a natural gas goes to methane based processes. So what do you say? All these three, refinery goes to steam cracker, natural gas to steam cracker, and then methane based process. Now we can say yes, the refinery, steam cracker, and methane based processes, what they do, ethylene, propylene, benzene, butylene, butadiene, toluene, xylene, methanol, urea. And these 4, 5, 6, 7, 8, 9, I think, 9, ethylene, propylene, benzene, butylene, butadiene, toluene, and xylene, methanol, urea, these goes to intermediate to product process. These are intermediates, and you can say, and we get these projects are so very important: plastics, fuels, solvents, elastomers, fibers, detergents, foams, lubricants, asphalts, nodes, resins, fertilizer, others. This is a schematic overview of petrochemical industry, which is very much relevant to, of course, all these are very important structural based, and we have to produce structures. So all these equipment, all these materials have a process one. Interesting this, we should know a little background about. I'm not saying we have to be expert of this, just know what we are talking of. Olefin plant, it says. Olefin plant is this one. Now this olefin plant, this is what I'm going to, I was interested in this, and before going to elaboration of that, just we know what it is. And this figure 2.2, it says this is a figure 2.2 schematic overview of an ethanol plant based on steam cracking technology. I am interested in this because it's very, very elementary. In fact, this figure shows a schematic of an olefin. It says this figure shows a schematic of an olefins plant based on steam cracking technology, which consists of a hot and cold section, and the hydrocarbon recycle. Hot section consists of cracking furnaces. Quench and primary fractionator. Cracking furnace is reactor of plant. Where feed plus recycle hydrocarbons diluted with steam are cracked. Hydrocarbons, that is feed plus recycle, that's hydrocarbons diluted with steam are cracked in gas phase into lower olefins, such as ethylene and propylene at temperatures around 800 to 850 degrees Celsius and pressure of 1.5 bar with residence times of less than 1 second. In quench, reactor effluent composition is frozen. By rapid cooling under production of high pressure steam. In primary fractionator, water and fuel oil is removed from reactor effluent. In cold section, this was hot section. In cold section, reactor effluent is compressed. Compressor we are going to talk. Reactor effluent is compressed, dried and chilled. In subsequent distillation columns, reactor effluent is split in its products. hydrogen, methane, ethane, ethylene, propane, propylene, and C4 plus fraction. Depending on specific plant, C4 plus fractions can be separated further into butylene, butadiene, X, and gasoline. Lowest temperature in cold section are approximately minus 200 degrees to minus 170 degrees Celsius at a pressure of 20 to 30 bars. These conditions are a necessity to make these separations possible. This thesis is related to improving chemical conversion concepts of steam cracking process. Actually, let us see here. This is, you can say, ethane. Let us say it happens. Here green, we can say this is cracking furnace here. Naphtha and ethane. Now we have these, we can say, structures. Cracking furnaces, we can say these are. Here are cracking furnaces. Now this furnace is quench here, goes to quench, and this is primary fractioner and steam this way, and we can say from here this, you can see it goes to quench. Quench, primary fractionator, as a primary fractionator, quench, and then go to acid gas. Acid gas which goes to dry, compressor and dry chilling. Compressor and dry chilling, and then here's hydrogen. But from there itself, compressor and dry chilling, it goes to, you can say, that's here mixed products, that is, here is methane, acetylene converter is there, and fuel oil this way, and then it goes to, from here it comes and meets here again like this for compression. First ethane we get here, and we get ethylene as well as NAPD converter, and we get propane, which you can say sometimes used in the gas, cooking gas, and propylene also here, mixed butane gasoline, and here we get hydrogen. This is just, you can say, kind of circuit, just to understand something. It's not exactly what it should be. A schematic overview of ethylene plant based on steam cracking technology, and of course there are so many structures involved in this. So you may say compressors are involved here, compressing. It is very important for civil engineers to design compressor foundations, tabletops, as we have said. And cracking furnaces here, we have to design foundations as well as structural steel arrangements of this. I have shown you cracking furnaces in my sketch, and all in my photos we are showing, and also we get very small foundations for all these are required, and pipe flows or pipe tracks are required. Nothing, you can say there's so much is involved in that, and temperatures are involved. You can say boilers, wash water, so many would be there. Wash water structure, boiler structure, cracking furnaces, and likewise you can say so much, and then small foundations and processing, etc. are required. And that's the reason I thought we should share it. What's cracking furnace, for example, we can see. I'm just trying to share with you something which is very important for civil engineers to understand, at least, if not fully. Something is better than nothing. So we can say, it's not coming full, let me say 225 or so. Okay, this is now cracking furnace. What's cracking furnace? Let us understand this point before jumping on to something else. We can say a cracking furnace consists of firebox, it says. A cracking furnace consists of a firebox and a side mounted stack, let us say. Just a minute, please. Let me put up my battery. It's cracking furnace. So I'll just read for you something which is good one in this case. You have to understand. A cracking furnace consists of a firebox. Here's figure 2.3. Let us see, this is figure 2.3 before moving further, and this is a schematic overview of two cracking furnaces. And this is, you can say, is furnace, furnace, and this is bottom burner. This is firebox. This is bottom burner and this is firebox. Here is convection section and this is stack. Side wall burner, radiant coil, and firebox is this. It's very, very simple sketch. You understand what I mean? So there is a good structure for this current steam online. Now this is, let's see what it says. It says something. We have to understand that also what it says. Now. Because we have to understand something before taking up. We should know concept of design, and that's very important. Unfortunately, just we cannot depend on information given. So process is very important that engineers understand, and that's why we study many subjects during engineering. But we have to coordinate. It is a part of coordination as well. Important coordination. We should know something at least. Means just understand what shall be impact of those equipment on our structures. A cracking furnace. Let us say a cracking furnace, let me blow up little. A cracking furnace consists of a firebox, as we said, firebox, and a side mounted stack. We have seen firebox and side mounted stack. Inside firebox, radiant coils are vertically mounted. Inside firebox, radiant coils are vertically mounted from roof of box. Amount of energy required for cracking process is significant. This process has largest energy consumption of all processes in chemical industry. We are talking of cracking furnace. Cracking furnace, we are talking firebox of that. That is, in cracking furnace there is a firebox. It's a vertical firebox, radiant coils, vertically mounted from roof of box. And the amount of energy required for cracking furnace is significant, and this was the largest energy consumption of all processes in chemical industry. And it uses globally approximately 8% of sector's total primary energy use. That is corresponding to 20 megajoules per kilogram C2H4. Energy is provided with bottom and or side wall burners. That we have seen wall burners. I just show you that. I've shown you that. Combust a mixture of air and fuel. Combust a mixture of air and fuel, usually methane and hydrogen. Methane and hydrogen obtained in cold section or some other fuel gas. Inevitably, significant amounts of carbon dioxide are produced, approximately 180 to 200 million tons worldwide. 180 to 200 million tons worldwide. Reduction of this amount contribute significantly to goals of Kyoto Protocol. If you reduce this 180 to 200 million tons, reduction of this amount contribute significantly to goals of Kyoto Protocol and the environment or greenhouse effect. NOx emission level bound limit design and operation by ever stricter regulations and pose a challenge of furnace designers that have you can see this radiant coil, and here is bottom burner, so firebox, side wall burners. These are radiant coil hanging from roof, and these are side wall burners. And we can say to deliver intensified furnace with maintaining stringent emission levels. Intensification is different for retrofitting and for new designs. So we have, of course, intensification is different for new and for retrofitting. In former, that is retrofitting, the former plot space of furnace is kept same, while capacity of furnace increases. Whereas in later, economy of scale favors construction of extremely large furnaces. To recuperate energy from hot fuel gases of firebox, A convection section is constructed inside stack to generate high pressure steam and preheat hydrocarbon and dilute steam for radiant coils. Now, figure 2.4, we have to see figure 2.4 gives an impression how furnace shown schematically in figure 2.3 looks like in reality. And figure 2.5 shows a schematic of a typical cracking furnace and a steam system for a cracking furnace fed with heavy feedstock. We have to see this now. And also, convection section is a collection of different convection banks to recover energy from hot flue gases of firebox in FPS bank, that is pre-feed heater. FPS stands for feed preheater bank. Hydrocarbons HC feedstock is preheated and afterwards mixed with small amount of dilution steam DS and subsequently heated further in a so-called HTC bank, high temperature coil. Main DS that is dilution steam. Main dilution steam feed is superheated in DSS's bank, dilution steam superheater, and mixed with heated HC plus DS before it is heated in another HTC, that is high temperature coil bank, to desired inlet temperature of radiant coil in approximately 600 degrees Celsius. To recover more energy from flue gases, a steam system is integrated into cracking furnace. More energy from gases, we have to recover more energy from flue gases. A steam system is integrated into cracking furnace and quench, this transfer line exchanger. Boiling feed water BFW we can say for steam drum is preheated. Let's see this first. A schematic furnace of figure 2.3 shown while being transported from construction yard to plant plot. And that's from technique, and this is this one you can say. Schematic furnace of figure 2.3. This is figure 2.4. We are talking of figure 2.3, and let's say here figure 2.3. That's the furnace we are talking here. A schematic overview of two cracking furnaces, and that's here two cracking furnaces, and this was actual boiling feed water BFW for steam drum is preheated in economizer bank to saturation temperature of typically 100 bar steam. In quench high pressure, steam is generated with saturated water from steam drum. Saturated steam is superheated in several HPSSH banks, high pressure steam superheater, to yield high pressure steam HPS, which is a product of cracking furnace. Overall efficiency of furnace is in order of 90 to 94%, means that 6 to 10% of energy generated by combustion of fuel is lost to surroundings. Bottleneck for further reduction is stack exit temperature. Currently this temperature is 150 degrees correspondingly Celsius. Further reduction of temperature cause condensation of acid components on convection bank tubes, giving unacceptable corrosion. Talking cracking furnace, and what we say in beginning, it consists of firebox and side mounted stacks. Inside firebox, radiant coils are vertically mounted from roof, and what we have discussed will come back again just for information. I'm telling you what you are doing. And now radiant coil which is discussed before. So what we are saying now, radiant coil, in radiant coil HC are cracked in hydrocarbon, actually HCs. Hydrocarbons are cracked in approximately 1 to 1000 per second to amongst other lower olefins such as ethylene. Ethylene, ethylene yields are correlated to feedstock and ethane yields typically 75 with percentages ultimate. Ethylene while vacuum gasoles yields typically 20 watts percentage ethylene. Side products are propylene, butylene, BTX and fuels such as hydrogen, methane, fuel oil. Furnace operating conditions, temperature, steam to feed ratio can be adjusted to influence yield balance between ethylene and propylene for heavier feed than ethane. Propylene yield up to corresponding state percentage can be very high, very significant economic impact in figure, now this figure 2.5. In order to obtain all these products in a purified state, a significant separation effort is required. Cracking oil requires inner reaction temperature substance. Now we come back to this. Let me see what is this. Figure 2.5 gives you schematic overview of firebox, convection section and quench steam system. HC hydrocarbons, DS is dilution steam. Remember, HC is hydrocarbon, DS is dilution steam, HPS is high pressure steam, FPH is feed preheater, ECO is economizer, HTC is high temperature coil, HPSS is high pressure steam superheater, DSS is dilution steam superheater. So this is what we have to understand now. What it says, let us say it's a key plan. It says let us say fuel air, fuel plus air comes here. Here is radiant coil, this heat up, fuel plus air is radiant coil, and then you can say there is convection section. This is transfer line exchanger. So this goes to radiant coil, leads to this one, that is transfer line exchanger, and here are HTC, DSS, H high pressure, DS. Just now we have seen which is DSS dilution steam, SC is hydrocarbon, high pressure steam, all these are here. Economizer, and you can say FPH is, just we say FPH is, I think it's missing, yeah, feed preheater. We have gone all this equipment. HTC, that is HTC is high temperature coils, HTC. DSS is, what's that? DSSH is dilution steam superheater, and we have HTC high temperature coil and economizer, and FPS is you can say feed preheater. Now these are flue gases out from here, has internal SC, and that is, you can say, there is hydrocarbon SC, and DS we can still say dilution steam, and here is main DS, and all this is convection section, and this is convection section as a whole, and from BFW is here, HPS here, and we can say BFW is not given here, no problem. Then we can say here steam drum, you can say transfer line exchanger, high pressure steam coming here, and here is STC comes out here. It goes to, after this fuel plus air charge, goes here to transfer line exchanger, and this is here, you can say crack gas, and steam drum is for that purpose, flue gases. So this is diagram of you can say, this is diagram 2.5, overview of firebox, convection section, and quench steam system. So this is a little bit studied here, and we can also see, we'll go to this before. Is there some other diagram? Let me see, which is important. Ideal chemical conversion concept for industrial production of ethylene. That we'll discuss it. Let us understand this first, because this gives us an idea what we design It is equipment design, or it may be. So let me read it again for your information. Here we were here, we are here in order to obtain all these products in a purified state, a significant separation effort is required. Cracking coil inner reaction temperature is severe, namely 600 to 850 degrees Celsius, which results in an outside tube skin temperature. Of course, outside tube skin temperature of 1000 to 1075 degrees Celsius. Higher yields are obtained when reaction temperature is increased. Higher yields are obtained when reaction temperature is increased, but currently this is constrained by metallurgy and caulking of applied cracking tubes in furnaces. Maximum tube metal temperature for tubes made of chromium nickel alloys is approximately 1150 degrees Celsius. In transfer line exchanger radiant coil, its effluent is rapidly quenched. In transfer line exchanger radiant coil, its effluent is rapidly quenched. Reason for rapid cooling of reactor effluent from corresponding 850 to 600 degrees Celsius is fact that primary products, that is lower olefins, can react further into more unsaturated and more condensed species. Dilution steam is added to lower hydrocarbon partial pressure, which reduces the secondary conversion of desired lower olefins. It also reduces caulking rate in radiant oil and transfer line exchanger. So what it says is dilution steam is added to lower hydrocarbon partial pressure, which reduces the secondary conversion of desired lower olefins, and also reduces caulking rate in radiant coil and transfer line exchanger. Deposition of carbonaceous residue results in a higher pressure drop and higher tube skin temperatures. Maintain a certain cracking severity, that is conversion propylene-ethylene ratio. Heat input must be increased, which leads to even faster coking deposition. And after 20-60 days on stream, cracking furnace must be decocked. This is a controlled combustion of coke on tube wall by a steam air mixture. Now, ideal chemical conversion concept for industrial production of ethylene from hydrocarbons. Just let us see what is that, and we will then jump on to our other subjects. Only few pages I will read, maybe in many sections we'll go through this theory, though it's not related to my engineering, but we should know something for purpose of doing successful coordination. We have to at least interact with people. What we should know means this is not exactly mathematics, but some theory, or some you can say better to understand. This review considers and evaluates alternative process concepts for production of ethylene on an industrial scale. A fundamental perspective is chosen, focusing on ability to create a near optimum conversion path from hydrocarbon C2 plus feed to ethylene. Critical conversion aspects are quickly achieving a high temperature at a low hydrocarbon pressure, and after a short reaction time, arresting composition with a high ethylene content by rapid cooling. Feature of an ideal process involves a maximum olefin yield, no remains of energy carriers or auxiliary chemicals in product. Minimal ecological impact, minimum energy input per unit product, high availability, and a low degree of complexity of reaction section. Majority of current ethylene production processes are in evolutionary redesign from earlier existing processes that's able to add a large amount of thermal energy in a short period of time and at elevated temperature levels in range of 600 to 1200 degrees Celsius, enabled by better high temperature resistant materials. Process concepts reviewed in this paper are examined from a different point of view, namely how well they meet criteria of ideal process. Specific energy requirements of processes are limited in available literature. Therefore, these requirements are systematically determined with, all right, let's say, 8 to for ethylene plant now. Now, this chapter is a version with minor modification, an article published by Industrial Engineering Chemical Research. Now we see this is figure 3, an input-output diagram for production of ethylene on industrial scale, and let us see process. So let us see here. First of all, let's understand C2H4 might come now. Here is a biomass, here is a natural gas, here is hydrocarbons, that's C2 plus, and here is auxiliary chemicals. That is ethylene, C2H4 we are talking, and it goes all here. There's energy here, and you can say waste here. This you can say ultimately overall is C2H4 comes out. Now what is process? Biological, oligomerization, that is CH4 upgrading, oligomerization upgrading, and then dehydrogenation and cracking. There are 4 ways, process routes. Biological, oligomerization, upgrading, that is CH4, dehydrogenation and cracking. And the input is biomass, natural gas, hydrocarbon C2 plus, auxiliary chemicals. Now in biological we get direct routes, C2H4OH dehydration, oligomerization CH4, synthesis gas based oxidative coupling, dehydrogenation, catalytic oxidative equilibrium shift, and cracking thermal catalytic. Here we get in this synthetic gas based oxidative coupling, Fischer-Tropsch catalytic conversion of methane or methanol, and direct heating, that is in thermal cracking, direct heating with gases, liquids and solids. In direct heating we get C2H4 here. So why is said here in say go back is the specific energy requirements of processes are limited in available literature. Alright, so plus software sector we say here that with fixed a wide variety of processes concepts is covered. The hydrogenation, direct heating and indirect heating, although none of reported processes fulfill all ideals. New combination of adapted firing furnace with ceramics reactors internals and shockwave reactor. I'm wasting time, right? No, not wasting time. It's very good information getting for your coordination purpose, because somehow you have to work in field. Even if you work in design, all this information will help you. And introduction is now what's ethylene? Again I say ethylene is world's largest volume organic chemical with a worldwide production of 117 million tons per year, in that is 275 plants. This means we have so many plants around the world. Ethylene manufacturing is dominated by thermal cracking. So thermal cracking is procedure, as we said here, thermal cracking. This means it is here. Thermal cracking, direct heating with gases, liquids and solids. So this is dominant here in this production. This is ethylene manufacturing is dominated by thermal cracking, and process of thermal cracking has evolved significantly from end of World War II until present. Plant size has increased from 10 tons to 1.7 million ton per year. I am telling you, I did work on 6.5 kTA, much more than that, 1,000. Feed stocks for thermal cracking are, what is that? Hydrocarbon C2 plus. Thermal cracking का hydrocarbon C2 plus such as ethane. We are going to produce ethylene, but here is ethane C2. So this is, you can say, feedstocks, feed, but it is ethane, liquefied petroleum gas, LPG we call it, and naphthas, gas condensates, and gas oil. So we have to keep this in mind for thermal cracking. Hydrocarbons are, and that was what is our feedstocks are carbon C2 plus, that's hydrocarbon, and such as ethane, liquefied petroleum gas, naphthas, gas condensates, and gas oil. Continuous research and development efforts are performed to achieve better ethylene world yield and lower energy consumption. In addition, use of alternative feedstocks such as biomass, natural gas, synthetic feedstock from fixture, troughs, methanol, and ethanol has also been pursued. Now in this figure 3.1 we see an overview of different routes to ethylene. On an industrial scale, some of these routes have not yet been developed to an industrial scale, and we can say figure 32, that is percentage change of world gross domestic product and global installed C2H4 nameplate capacity. Well, is that what you see? There's one here is some of these routes have not yet been developed to an industrial scale process, but they have potential. They have potential to do so in future. For example, a direct process from biomass to ethylene at this moment is not capable to produce ethylene at an industrial scale. However, biological industry is promising and perhaps may be a topic of interest. Prosperity of a society is one of indicators for demand of ethylene. This is ethylene demand is prosperity indicator. An indicator for global prosperity is gross domestic product. This figure shows annual change of both world GDP and installed ethylene nameplate capacity. And this figure confirms that world GDP is a good indicator for demand for ethylene. Because economy in China and India is growing rapidly, global prosperity most probably shall allow grow, and consequently demand for ethylene is expected to grow. Current ethylene production facilities are heavily dependent on availability of hydrocarbons from crude oil and light alkanes from gas field, which will not last forever. This implies that we have to improve current technologies and search for alternative processes to produce ethylene in a more efficient way. Among others, a measure for progress to more efficient thermal cracking processes decrease in amount of energy required to produce 1 kilogram of ethylene. Significant improvement to reduce specific energy have been obtained, and need to oil crisis in 1980s. Figure shows progress over last 50 years. Considerable research has been conducted to improve thermal cracking process and to find alternative routes to produce ethylene. During oil crisis, research objective was to crack crude oil directly. This generated several thermal cracking processes such as adiabatic cracking and fluidized bed cracking, among others. Often a technology used for thermal cracking is derived from another technology. Current state of art thermal cracking for this can be considered as an upgraded fired heater. Direct heating process, for example, those using an advanced cracking reactor are derived from acetylene manufacturing process. Fluidized bed technologies find their origin in fluid catalytic cracking technologies, generally a process that can add a large amount of energy at a high temperature level in a short period of time can be used for thermal cracking. Through this type of evolutionary process development, Focus is on what existing technology can do and how this must be modified to obtain a good process for ethylene. This way of process development makes it hard to develop ideal process for production of ethylene. Developer is not focused on conceptual process design but rather on design of an existing process. Percentage change of world gross domestic product and global installed C2H4 plate capacity. And here is that, if you see here, 1986 onwards to 2004 at a gap of 2 years is 1986-88 likewise, and we can say here percentage change, and that is, let me bring down percentage change here. World GDP is given by this here installed capacity ethylene. This curve gives world GDP. World GDP, you can say here, world GDP is 3 point something, say 8 or 7, goes here up, then goes down. You can say in 1988 it was up, and in 91 it is down, and again in 92 it's up likewise. You can say this is maximum here, 4.5, that is installed capacity, and world GDP is, this is installed capacity, I'm sorry, and this is world GDP. This is GDP here, you can see this is GDP, and this is installed capacity. You can see it's this much, and you can see here 8 point something percentage change, and you can say it is installed capacity. So installed capacity is higher here, percentage changes, percentage change. What GDP is this? Installed capacity anywhere, and that is installed capacity, that is this one, and this world GDP is this. So that's relation shown, percentage change of world class domestic product and global installed, this percentage change and nameplate capacity. So we can see this also, that decrease in energy required to produce a kilogram of C2H4 is ethylene, that is decrease in energy on 1950s at the gap of 10 years up to 2010, you can say decrease in energy. So it was scientific, it was specific energy, and that is in so much high, and that's coming down, and you can say here it goes down in 2000 before 2010. So you can say decrease in energy coal required to produce a kilogram of C2H4, and I think we will now go back. I will show overview by master. We'll go later on. This will come back because I cannot take whole time here. Because of purpose of page 40, we are now still come back onto this. So what we have done, we can see that we have gone through this with nice and next generation steam cracking reactor. We are talking of, and just a brief look on that, so you can close this file. And here is what we see. In fact, this is, we have gone through just to understand what we are talking of. It's very important to understand rather than just jumping onto this, because we are cell engineering community and we have to know how world moves, and this is our limit. We understand process first, so we can take better position in designs, we can understand well, and that's what it is. And we can say we have to move further on this, and we have to see in office 5 o'clock in the morning. We have cannot stay all time onto this issue, and I'll jump onto other one for closing it. Let me see what we have talked of steam technology. You have seen this also, we have seen this schematic overview of processes, and here you can see we have gone through this file, and this very important one. As I said, I just remember I could just copy this one from this file to my construct coordination engineering. The source I'm telling you, it's very important source. We now jump on. I close this file for time being, and it's of course big file. So we go on to our quality file and our coordination file. In this coordination, we have been discussing various views, and I was talking to you on this sketches. as I said, here is this. I'm talking about this plant, ethylene plant, first ethylene plant here. I was talking to you about this, and this is here. It was the same sketches here I put in. Well, this just to understand that, how to understand this file. It showed to you, this is that file, this publication, Next Generation Steam Cracking. If you want to see that on web, you can go there on this. And also ResearchGate, also this is schematic view of ethylene plant, and that's this one. So this and this are here. You can see, if you wish, I can show you just now. If you take time, you can see research.net, you can see here, and also you can see the okay. Moreover, I'm interested because I worked on these compressors long back when this, and why I know I worked on cracking furnaces foundations, and I saw one of many other equipment there, and so many other foundations are involved, and so I was interested just to let you know. And all these terms I could not understand that time in 2000. Because I didn't know process engineering. Of course, I'm not expert of that. Still now, I don't know anything. Just because of foundations, I've learned, for example, I've learned the vast water structures and the boiler structure, auxiliary boiler structures, cracking gas compressor, foundation, tabletop, ethane and propane. Likewise, many other foundations and related pipeline work, related pipe rack work and foundations and infrastructures and all those. Very complicated one. This usually is, this was, then we go to, this is actually that plant for which I'm referring to all this. This is called process area of that plant. And this is very complicated arrangement here. This is all supportive anyway, however, but this is very complicated here. That's why I'm interested to discuss all this with you. And this also same here. So many structures are involved, which at that time you cannot even see what we're talking of. And here, this is water cooling water basin, seawater basin for use for purpose of cooling. It's very big. It's a part of that plant. So we can say, and also here we can say, this is a different one. We call it structure. Now, what I would say is this is hospital. I have discussed, and this pictorial view. I think this is not exact one, but let me see whatever it is. It's a kind of hospital building, and this is also very good for civil engineers to understand. It's not ordinary one. Of course, it's one of many hospitals available. I try to find for you where I was involved. And there's another LNG plant for which it's very important to understand. I showed a file yesterday about precasting plates in place of normal or conventional formwork. We talked of that last time, and we can say this is actual, as I discussed with you, LNG plant here. These tanks, 4 tanks we did, and this is image of one and internal work of other one, and this actual site. You can see this was done. It was in 1996. You can think 1995, yes, 1995, 96, 97. And you may say it's about 77, 76 meters diameter and 51 meters high. It's a cylinder of wall thickness 800 mm. 800 mm, that is external containment, external tank, the one purpose of covering if there is any problem within inside metallic tank. That you can say cryogenic tank inside, 9% nickel with that, and temperature of gas is about minus 160 degrees Celsius. There can be any problem, any accident in case some leakage. In that case, this RCC or PSC, RCC cum PSC tank, external tank, takes care. And there's a cupola above, and there's a platform above as well. That is, you can say, beauty of this. And this is administrative part of that plant, not LNG plant but other plant, but that can also be for LNG plant if you wish, no problem. We should have some administration section, and we should have some other section for purpose of that. And this is cracking gas furnaces I was talking about. Cracking gas furnace, we just talked cracking technology, we talked of cracking technology. And that's where it applies of high pressure, high and high temperature, short running, short time, as it said. So we go back to normal discussion now. Plate 13 is our this house. It's very important. So what we said is, so what I was actually interested in coordination, because without coordination we cannot do anything, and quality has got relation to coordination, and that quality is very important from every point of view. We cannot just run blankly. We have to understand facts of life, and that's very important point, facts of life. And when we talk of quality, we cannot talk in isolation. Quality cannot be considered to be achieved in isolation. We should know that point, and that's a problem actually. I don't understand reason behind that, why we have failed. Maybe somebody says we are in quality, but I don't agree with that. There's no quality at all, to be very frank. Quality is not understood by people. They think quality control itself is quality, but I don't agree with that. Quality is quality, means it should exist in every walk of life, and in particular in professional walk it's very important. We cannot sleep without quality. And now I am only naming Bharat, India, but I think it's not only applicable to us but also to many others that we don't have quality. So my worry is little different, very different, and we have to understand that point very clearly. What is quality? Why we have lost it? We should gain it again, or I think we have not lost it, but we have not even done it, and that's why I'm interested in quality engineering as well as coordination engineering. And that's the reason I clubbed this term in my title as well: quality and coordination engineering, projects, works, and communication, without which we cannot do anything. We have to understand this point very well. Very well, and if you don't understand this, we cannot understand anything. Quality engineering is a must in designs, in manufacturing, and in construction. And we cannot do anything otherwise. That's what we have to understand, and for that we have to understand requirements. Requirements, as we discussed on this file, next generation file we discussed, and actually that is a requirement. And this requirement is not only for ethylene, it's for all procedures, all works, all objects, all projects. If I'm going to construct or I'm going to design and construct some project, I should know what we are going to design, and that's very common. We are going to do institutional work, or we are going to do residential commercial project, or we are going to do commercial projects, or we are going to do some other project, some other work. We should know before attempting that what is purpose of our design, what is use of that building. That's very important from title, or from that we understand. But if you don't have that, or even if you have to understand basics. That's why requirement, and that's what I say requirement is. Requirement is not defined, it is to be understood. Definition cannot give everything. You have to understand yourself, what we have to do. And based on that, we can decide what level of quality do we intend to have. Quality means we have to fix quality ourselves. Nobody will come and say, this is quality for you, do this. Nobody will say that. Engineer has to decide quality level. Design engineers are responsible for that. Other engineers are responsible for that. What's purpose of structure we are doing. And I'm talking of structure, in fact, not other finishing items. Finishing items are important, but not that is important. The structure is because structure means survival. And if structure cannot survive, your other items cannot survive. Life cannot survive. Just imagine if we have a structure, let us say we design for 50 years, we construct for 50 years, but it doesn't work for 50 years, it fails in 10 years. And so what to do? Suppose you don't have quality, you maintain quality and structure failed in 10 years, or in 20 years rather than 50 years. We have lost 30 years or 40 years, of course, and that's a major loss. Your return did not come. Return is very important. You lost natural material, you lost your money, you lost everything. So what is say work's quality cannot be compromised, that means it is we cannot compromise quality. We do not intend to compromise. And we don't blindly follow whatever system exists, because it's whatever system we follow or we move, we design that. Nobody else designs it for us. We ourselves design our system, and we have to follow that system, whatever we design. Of course, continuous amendment is required, but follow-up is also required. And if we don't follow it we don't follow it religiously and professionally, we can never understand what point is wrong, what defect exists there, where we have failed to understand. All that we have to know. And that is the only reason I am very much inclined to combination of quality and coordination. I started with quality, but I have clubbed it to coordination as well. And communication, of course, exists there. I cannot separate communication from anywhere. And of course, I can claim quality system may fail or it may not work according to intention we had, but whatever we work, there must be quality at least in activity, if not everywhere, but we don't even care for that. And that's the point. I'm talking very seriously about our country, though it applies to many other countries, but I have every right to talk about ourselves. And we have to see ourselves where do red lines occur. And red lines means certain problems which obstruct our ways to reach that level. We can say, yes, we have achieved, and I should say, yes, I got quality levels in my approach, in my group approach, in my organization approach, and ultimately my nation's approach. These red lines we have to understand. Of course, these are not it is not something we cannot, it's known to us even then. We have to disseminate all time. We have to understand how far can we go in quality and in coordination. And if we cannot do that, papers are written, everything is done. What I say, somebody should read paper. And if you don't read paper, there's no meaning of writing. If I write a lot and people don't listen to me and they don't read it, so what can I say? You can yourself judge what should be said in that. Quality should not be down, but it is down. And that is the reason we deliberate on this, how to make up quality levels and how to do better job all time. And I don't say I claim it, but intention is that. Claiming is not enough. I cannot claim my work is best one if I am not sure of what others have done. So we should be clear about that. How much I accept my work, I have to decide myself. You get my point. I have to examine myself what percentage of application I am successful in. If I say no, I am not successful, then I am not a professional. Successful means, okay, there may be some error, but why should there be error when a professional works? And that's a very important point, because you don't want to accept reality of life. That's their problem. You don't accept reality of life. And if you don't accept reality of life, it's a very big problem. And we should be very, very smart in this case. Smart in every way we should be. Or else life becomes very dull and difficult. And here is our coordination issue. Say coordination, engineering is a must on every project, without which no one can move. And coordination means every work in that we can coordinate only when we know all about that project. I'm not saying you should be professional in that project. There is no professional. Every project is professional because every project has got many professions access to that project. And we should accept that point. If you don't accept that point, I think we do mistakes. So we start with saying only, every time I say design construction, we always say design construction, and it's easy to say something. It's easy to say something we talk of, and we say designs, construction, and controls, which were very interrelated, which of course are interrelated sections for achieving success. And that means to work successfully from start or commencement to completion of that project. And that must be applicable throughout project stages, with all works be smoothly affected in compliance to what definitions to exist. You have to understand these points. These sections, stages are not initial concept designs. You have to understand that, how coordination works. For that we have to understand what we are going to do. And once we understand what you have to do, you can that speak frankly to others. If somebody questions, some reporter comes to you and questions, and you don't have answer, then that journalist may write, nobody was available, or somebody answered like this, and that answer may not be your answer. So I say coordination is not easy, but it is continuous, and that is only a problem because people do not want to do anything. That's bad, but they don't even maintain time. They don't even do anything or whatever thing is required to be done. Coordination is that world where we can see everybody mentally. We can see responses of people, by people, for project, by project. Questions are raised by project and responses are given to project itself. Important, this is really important. We can see that these sections are initial conceptual designs. We have to get into view. Coordination engineering is not defined one, but you define your engineering your way. Ultimately, definition means information. Information means reliable information, authentic information. Sometimes we just in hurry up, or you can say we in haste, we don't understand anything, but we say, okay, let it go, and let it go. No, that doesn't work in engineering. Engineering does not allow any let it go. And that is, you can say, beauty of engineering. It doesn't allow let it go. It wants to get facts. It wants to get facts, in fact. In coordination engineering, that word, I have tried to find more and more on the internet, but it has been, I'm just reporting that I feel disappointed, very much disappointed in coordination world, that people do not know. If they don't write, means either they are unaware or they do not know. I cannot say engineers are unaware, they know very well. But even then, they don't do it socially, practically. What we should think of to improve our quality system and quality, I am saying quality system and quality combination, and there you can say coordination engineering has a rule. Coordination engineering applies there. It may be design world in engineering, or maybe construction world, or we can say whatever other important where facts are imported, you can say Everything else is done. We have to understand these integration, validation, all these terminology we use, but in works, how much do we use that's a point of concern. With all required sections, related activities import total dedication from quality. It's all sections, whatever we have, these should be considered comprehensively, collectively, for purpose of whatever we do, that must function. In fact, we do not do any work that does not fit in project. We try to minimize construction cost, but also maximize life use, maximize power of life, in which coordination is very significant. And it can be plainly spoken that engineering coordination is an only formula or discipline to reach workable, consistent and competent solutions to achieve success in life for performance. So what I'm saying is, in this action of quality and coordination, we have to be very clear, we have to be true to ourselves. We should not try to just, skip our responsibility. Our responsibilities are immense. Civil engineering itself is very much responsible field, like mechanical field, electrical field, because electrical field is also very important because it gives you family level, joins family. Yeah. So we have to move on to this talk now. From technical to coordination world, which is very important part in this talk, we have confined ourselves to coordination engineering, and that's very important factor. We have to understand that the coordination engineering is not that easy as you think. So it is a practical one, but it takes your attention all the time, and continuity is very important. Now it's 13 degrees, of course, down. I'm feeling cold again. Real field is 11. And we have to understand facts also, facts of life, facts of engineering, facts of projects. We cannot take everything for granted. We cannot simply speak. We have to do something importantly. We have to think something, and say, we have to go this way always. We have to see that what we do is of course useful. And I tried many points in coordination world. Let us see if we can find more. What is coordination? Coordination in construction works. In construction works, if you say in construction, what Google says in construction. Let us see what is construction. Construction coordination, let us say. And coordination can be seen as a process of managing resources in an organized manner so that a higher degree of operational efficiency can be achieved for a given project. And that is coordination is a PDF communications and coordination construction project. Let us see what it says. Can it be useful? Coordination can be seen as a process of organizing resources in an organized manner so that a higher degree of operational efficiency can be achieved for a given project. Social network matrices are constructed using different centrality measures. Says these measurements are used to explore association between network centrality and coordination for a construction project. Network centrality affects ability of an individual to coordinate for a construction project. Network certainty affects the ability of an individual to coordinate actions of others. Following questions guide this. What is effect of network centrality on coordination? How is actors' ability to coordinate projects related to its structural position in communications network? Multi-layer test designs developed to explore this relationship in a project-based coordination of Dabhol Power Company construction. There are three major findings from analysis. First, centrally positioned actors show more coordinated activity. Second, P15 is index of certainty is the most important prediction for coordination. Last, influence of an actor is associated with coordination more than actor's performance. That's what says. It's not very much, if we say this, the full text. What's that? Full text. Let us say here. And this problem is communication, coordination. Let's see what it says. Down full text is here. Problem is these people don't allow clearly what you have to see. If we say here, it's there. I'm downloaded this. This is communication coordination in construction projects. It is a communication and coordination in construction projects, liquid housing, and this is 27th April. What it says, I think, is PDF already you're looking at. It's for here you're looking at this. Let us see. It's a paper also. I'm just trying to go to this. Construction Management Economics, 2009. It's liquid housing. It is University of Sydney. Says coordination. You can say just see coordination. Coordination can be seen as a process of organizing resources in an organized manner so that a higher degree of operational efficiency can be achieved. So I just spoken that now. Let's say coordination to be coordination in construction. Construction can be viewed as a process of putting together all materials in an orderly and timely manner by utilizing relevant resources to complete a structure per design specification and quality standards. Building construction refers to process of adding structure to real property such as residential, commercial, educational institution, hospital and sporting area. Civil construction is adding infrastructure such as roads, railways, airports, harbors, dams, mines and golf courses in environment. And industrial construction deals with large projects such as pharmaceutical, petroleum, chemical, power generation, manufacturing complex. Previous studies on construction organization highlights need or requirement for understanding complexity factors for construction industry, which deals with uncertainties and interdependence and inefficiency of operations. Process of construction depends on complexity of finished structure, requires a high high level of coordination high level of coordination among all professionals and trade persons from design office to construction site until project is completed. Persons involved at higher level team consists primarily of project leader, construction leader, as a digital manager I'm saying leader, same project, construction leader, commercial leader, manager, quality leader, manager, project control manager, design managers, and environmental and heritage manager or leader. Architect, of course, under them are frontline superintendent and supervisory staff, which consists of construction engineers, project control engineers, project architects, quality engineer, and electrical and services engineer. However, most common type are design, build, design and build and management contracting. Design, build and organizing contracting in design and build arrangement. Architect or engineer acts as project coordinator in design and build arrangement. Architect or engineer acts as project coordinator with the role of designing works, preparing specification and producing construction drawings, administering contract, tendering out works and organizing works from inception to completion. In design and build approach, owner produces a list of requirements for a project, giving an overall view of project's goals. Contractors would present different you can say what you should say proposals, of course, different you can say it's gone. I think I missed that page, is it not? Therefore, client could take contextual role. Where is that? I think I made a mistake. This column is the problem actually, you know. What I was talking is how I say is contractor would present different. Oh my God, this crossing is very important. Different ideas. I think column, I think it's not good. Different ideas about how to accomplish these goals. And owner would select preferred idea and hire contractor or consortium. This is in contrast to a design build contract, where project is completely designed by owner, then bid on and then completed. In management contracting arrangement, client could have an active role in procurement system by entering into separate contracts with designers. Construction manager or leader and in individual trade contractors, if so desired. Therefore, client could take on contractual role while construction or project leader or manager provides active role of organizing separate trade contracts, ensuring that they all work smoothly and effectively together, or client can have a manager to manage it all on their behalf. Well, this is only. Now we focus our effort on determining effect of network centrality on coordination. Building upon established coordination theories, we investigate differences in coordinative activity between individuals with high and low network centralization. Central research question may thus be phrased as: are centrally well connected people able to exercise greater coordination within network structure? Does an individual's potential for communicative activity become reflected in its actual coordination score? Do data reflect theories of centrality and coordination? We investigate following subproblems for this: whether high network centrality increases ability to coordinate, or whether low network centrality decreases ability to coordinate. Which says we determine like this: if one or two is about true or not, which measure of centrality is most potential predicted, which measure of centrality is most potent predicate for coordination, degree, closeness, or betweenness, whether our centrality correlates closer to coordination. Exploring relationship between centrality and coordination. With an understanding of what this study sets out to achieve, we continue with look at how social network analysis have been performed in the past. Coordination theory is collated and synthesized in a way that allows application for this study. Review of literature will discuss established concepts and mechanisms used in studies of centrality and coordination. We seek to answer questions such as: does higher one network centrality increases one's ability to coordinate? Does inverse also apply? Which measurement of centrality is most useful predictor for coordination ability? Is in or out centrality more important or more powerful predictor indicative of coordination ability? Introduction to centrality and coordination. In a purely graph theory sense, centrality is state or quality of being central in a network structure. Centrality is a structural attribute of nodes in a network, an attribute not of actors themselves, but of their structural position in network. Measures of centrality are based on attributes such as closeness, degree, or betweenness of a point. In a social network, centrality has been defined by leading social network researchers as a measure of potential importance, influence, and prominence of an actor in network. Therefore, it can be argued that potential importance, influence, and prominence of an actor are important indicators, and prominence were designed for identifying key individuals in a social network. Freeman defined three measures of centrality and explained their structural implications. Three measures identified were degree, betweenness, and closeness. Three measures are degree, betweenness, and closeness. Freeman stated that degree of a point seemed to be an index of that position's potential for activity in the network. Betweenness is extent to which a point falls between others on shortest path connecting them. It was taken to be an index of potential for control of communication. Closeness measures distance of point to all others. This was viewed as a measure of independence from control. Accordingly, kinds of centralities imply three competing theories of how centrality might affect group processes. Coordination is an abstract concept that is difficult to measure quantitatively. It has been measured using a combination of other factors such as centrality and strength of social ties. Coordination is primarily measured using qualitative methods, which identify people who have potential to lead and influence others. Traditional approach to coordination was to delegate most authority to a single actor. Authority was to secure coordination by control from top, a coordination by command approach. This notion has been a contentious issue mainly because of difficulties in selecting a suitable governing body. Contemporary thinkers contend that it may be timely to consider whether an organization should be conceived as constituting a social network. Minner argued that coordination is multi-layered, involving orchestration of relationships, not only at headquarters, but also at regional, national, and field levels. Consequence is top-down principle agent of perspective of coordination needs to be reconsidered. Measuring coordination through centrality. Formal properties of centrality linking structural position and coordination of small groups were first documented. Then we go back in MIT experiment 1950, then 1950 and 51, latest 1970, Freeman 1980, replicated MIT experiment with a group of 5 subjects based on 4 different structural forms. Visual and audacity, we vision that all these 3 communication paths were restricted on structural forms and performing group tasks with controlled communication links. Researchers were able to measure level of perceived control, independence and activity. Centralization of each position in the structural form was measured based on betweenness, independence and activity in post-experimental questionnaire. Participants were asked to identify position of person who acted as a leader. Majority of participants identified most central position as leader. Study found evidence that centrality is associated with leadership. We take this finding further to test whether centrally positioned actors show more coordination activity. Now hypotheses are shown. Hypothesis 1, that is centrally positioned actor show more coordination activity, and hypothesis 2 is betweenness is most potential predicate for coordination, and third is hypothesis 3 is our centrality measures are most potent predicate for coordination in directed graph. So we can say centrally positioned actors show more coordination. Let's see what's that. I was just trying to go into some philosophical study of coordination, though it's not directly linked to that one, but still if we use that, and we are just putting in coordination. Let's see, for purpose of review, maybe we take up some of this tomorrow. So I would say that I would say in coordination, you can say, let's put in coordination better, coordination study, coordination study, you can say in this case. Okay, name is coordination study, is it. So in study, so we can say that in study by Freeman, centrality did emerge as an important structural variable, but not traditional kind of centrality based on closeness, independence, you can say. Instead, experimentally important kinds of centrality are based on potential for activity. and control betweenness. Level of certainty in determining group leader was calculated using an analysis of variance. It was found that levels of certainty rate is same order as predicted by control-based measures, central betweenness. This support the argument that betweenness is key to leadership, since betweenness is based on potential for control of communication. This outcome makes intuitive sense. Perceived leadership is related to what's termed control potential. What analysis of 30 years of major social psychological journals performed a meta-analysis on fields effects of centrality. They studied these aspects of individual behavior as part of a group task, leadership, satisfaction, and messages, and it was concluded that betweenness index is you can say most powerful. Betweenness index is most powerful independent predictor of effects of centrality. Individual in most centralized position in terms of betweenness is likely to emerge as leader, to be more satisfied, and to participate more in task solution. Moreover, this indicates that potential for control of communication seems to be uniquely important in development of leadership in communication network. These behavioral characteristics support findings betweenness. So we will see this as something that is very, very theoretical, and I'm just trying to explore coordination issues. We'll continue on this. Just let us see what content is file. Actually, we'll take some time also on this because the important point is what we have to do is call personnels and training sets, and these are all we have to do. Our is engineering work, and I don't think we have to concentrate only on this issue, because we'll look into that sometimes. It's of course looking interesting. Results and discussions, and we'll see this is a good one. I got by chance this file, and we will look into this. How can we move on this forward? Meanwhile, to go back to my own work. Let me see what it says more on this. Coordination in construction industry and this designing build, I think we did it. I don't know. I visited this page on 13th, so leave it. And I say this is role of project coordination in construction projects. This is let's say if we can do this. Role of project coordination in construction project. Let me see what it says. Can it be useful to me or to you? Role of project coordination in construction project. Let us say Professor Reshma Shah, Faculty of Technology, University Ahmedabad, Gujarat, what she says. Let us say what our people say. Let me just read it for you. Abstract is Professor Reshma Shah says, a wave of development has now proliferated across country India. I'm great to say that somebody is there at least to talk of this. So thanks Reshma, Professor Reshma, Faculty of Technology. Let me see what you say. Our people should know what level we have actually. A wave of development has now proliferated across country. In such times, construction industry too has amalgamated itself in this chain of progress. Advancement are gaining widespread momentums. Projects require to fructify with holistic approach. This calls for effective management, organization, and successful implementation of projects, one where there is no room for error. Project coordination is a tool which can be applied for attaining better and effective results in project success. This study the instance of a complex and multifaceted project. Mahatma Mandir Convention Center establishes requirement and role of project coordination. It also exemplifies how successful coordination is a boon in entire project life cycle. Lessons learned from this can be integrated in other projects, thereby aiding in execution, operation, and successful implementation of project. In these keywords, she gave a project coordination, bid process management, design changes, approvals, billing and escalation, extension of work. How many pages are there? Let me see if you can help them. Why not use them? I'm for your information. I'm just printing it out now. And let us see what our people say, and we have to see objects. And we have to see what they think about and its role of project coordination. This is from International Journal of Engineering Research and Technology. Let me see if we can take note of that. Why not to? Because we have to understand our people as well. So let me take print of this and see how can it move. We can do something with this now. So you can also see that loading preview. Now it's coming in, and we'll take print of this. I'll say how does it work. It happens, and I like all these things. Of course, coordination it is, and I'll take save. I save it off for future reference as well, because we have to collect information from various sources of what coordination people think it is and how it should be. That point we should understand very well, and if you can understand that very well, it's fine. I'm not able to save it on here. Let me see if I can save here, save as here, and we'll save this file in coordination itself, and let's say what's that coordination. I should put in coordination here, so that we'll coordination, role of project coordination. So we save it like this, and now we study this. In fact, what you say, let me see, I should go back to study that one. That paper I take it off. Okay, I'll keep it, so I'll take more points here. Let me see what is it's here, or we can say. So it's International Journal of Engineering Research Technology, role of project coordination construction project, and here we say, here is this professor. So here what the introduction is. Let's say here says project is an organized unit. Introduction is project is an organized unit dedicated to attainment of a goal. This is what she says. According to her, project is an organization. To professor, project is an organized unit dedicated to attainment of a goal. Successful completion of developed project on time, within budget, in conformance with predetermined program specifications. So this is quality. You can say budget is cost, time is time, and predetermined program specifications, and that's called quality requirement. You can say time, cost, and quality is a triangle, so starting is fine. It can be defined as a temporary endeavor which is designed to achieve a set of goals, such as product or service which has a definite beginning and end. That is project and service which has a definite beginning, and that's also fine. That is project actually, not product. Service, okay, no problem, and then is typically undertaken to obtain some benefit or to add value. Recent advancements have made it possible to now undertake complex and technologically intense projects. The deployment of project management strategies aid in such undertaking. So now project management, she defines how it looks. Let us see. Where's that? Project management is an organized venture. It's an organized venture for organizing projects or managing projects. He defined, the professor defines. It involves a scientific application of modern tools and techniques in planning, scientific application of modern tools and technique in planning, in financing, implementing, monitoring, controlling, and coordination of unique activities to produce desirable outputs in accordance with predetermined objectives within constraints of time and cost. Project coordination is one such vital tool which provides effective management amongst various components of a project. Project coordination is a tool which can be employed for attaining better and effectual results in project success. Okay, that's fine. Elementary is okay. It's a tool or process, you can say, or whatever it is. Now, consultants, contractors, subcontractors, specialists belong to, you can say, different disciplines. All this makes coordination more complex. Project leader alone shall not be able to handle workload and will be drained. Moreover, will not be able to invest resources on other much important issues. In such cases, role of project coordinator becomes crucial. This study through instance of a complex and multifaceted project. Mahatma Mandir Convention Center establishes requirement and role of project coordination and how successful coordination is a boon in entire project life cycle. What is the requirement of this study? It says success of project is chief requirement of any project, chief aim or objective. Coordination plays an important role in this success. Let me blow it a little. Coordination says, what is that? I miss. Yeah. Coordination plays an important role of this success parameter, having considerable effect on outcome of a construction project. Despite this, projects tend to fail or fall short in success. This leads to requirement of studying coordination techniques, current issues and methods to improve them. Coordination can be seen as a process of managing or organizing resources in an organized manner so that a higher degree of operational efficiency can be achieved for a given project. Objective of this study is to identify project coordination tasks involved in all stages of project life cycle, whatever name of this project is, you can see, and to determine level of effort required to achieve coordination goals for issue and listed in pre, during, post. Study, scope of study is whatever it is. Let's go further. Study conduct is a project specific study. Qualitative interview and opinion survey is through responses of personnel from client, contractor and professional advisor, and it reflects their perspective based on experience. And what is methodology is? Through literature study, 5 major coordination goals were identified from study of this project coordination tasks which occur during life cycle were enlisted and classified in these goals. Major tasks impacted project and which high level of coordination effort was required were studied in depth. Nomenclature followed for these tasks or issues, research methods. Case study for this project, Mahatma Mandir phase. Mahatma, this project center is an iconic building constructed in honor of Father of Nation. All right, what is leave it? That's all. Capital characteristics central vista is an antrinode leading to assembly complex, and that is one way and as a new connect to future. Complex is spread to 60,000 square meter. This inspiration from life, okay, leave it is planned as a state of art complex with various modern facilities for hosting events. So let us say what is there in this study of bid process management. Leave all this. Issue 1, bid process management, and they say bid process management, study of design changes, study of approvals, study of billing and escalation, study of extension of work being. So let us say issue 1, bid process management. How long is? Let us see first of all. Okay, this is whatever design changes, then approvals, and then we can see issues for billing and escalations, and then we have here extension of works. I think we should go one by one. Let us see our levels of thinking. That's my approach. Means how far can you think, or you can talk on your papers. We can do something else also. That's point where we think so is right. Yeah, I'm talking of coordination, my writing, and we're talking of this, you can say, quality as well. So let us understand how people think we do, and all those allied people. Now, study of bid process, I little zoom it further. Study of bid process. This is study of bid process includes study of contractors and PMC tenders, bidding process, initial and detailed screening, technical and financial bid, concept presentation and final selection. Contracts call for an EPC work on turnkey basis for business center and exhibition center. Method of selection adopted was QCBS. Quality 60%, technical 10%. Quality 60%, technical 10%, and concept presentation 50%. This is in quality 60%, they bifurcate. Technical 10%, and concept representation 50% and cost 40%. Well, I don't know what you mean by the method of selection. Is that method 60%, 10% at technical, and concept is present 50% and cost 40%. This concept, I think so. Well, let us see what they say. Quality is this. A minimum 75% was required to be qualified. Okay, out of this 60 and 40, 75% was required to be qualified. In total, 11 bids, responses, and it was healthy competition. Well, I think 11 bids is also waste of time. In fact, initial screening comprised of average annual turnover. Initial screening comprised of average annual turnover and within last 3 years. General experience within last 5 years. So, average annual turnover last 3 years, general experience last 5 years, and specific experience in which only 4 bidders qualified. Detailed screening consisted of financial stability, capability 38 marks, technical capability 18 marks, experience 44 marks. Only 3 bidders qualified for concept presentation after obtaining minimum 75% as required. Only 3 bidders qualified. Concept presentation 50% had criteria such as optimizing land utilization, build to open ratio, and connectivity, structural clarity, and meaning, etc. It was just by experienced personnel from client and professional advisors team. Contractor E obtained highest marks. In financial bidding 40%, contractor E bid 135 crores, and in combined valuation was H1 bidder and was hence awarded work. Approach and methodology 15 marks, personal 50 marks. Both bidders qualified for concept presentation after obtaining minimum 65% as required. Concept presentation had criteria, that is 15% had criteria such as overall experience of work, similar type of project, maximum volume of work handled, understanding of objectives of project, etc., which was just by experienced personnel from client and PA team. PMCA obtained highest marks. Financial bidding 30%, contractor A bid 1.23 crores, and in combination evaluation was H1 bidder and was hence awarded. Design changes, this was bidding actually. This was only bidding we talked of here. Let us see study of bid process management, now study of design changes. Let us see. Study of design changes include the collection of all changes. Collection of all changes which occurred in course of projects such as location, site layout. A major change was location change which occurred thrice. Science City, helipad, Central Vista, and consequently area was changed. 30,419 meters square, 41,113 meters square, 39,095 meters square. This led to BOQ changes, 135 crore, 193 crore, 233 crores. Other changes included orientation change, namely building length was elongated from 132 meter to 170 meter. Design philosophy change from textile industry to Gandhian philosophy. Cladding change, sandstone converted to precast panels. Roofing system change, concrete sheeting to natural grass turf. Now this is for design change. Now approvals, issue 3. Study of approvals includes study of methods. Study of approvals included study of method. 135 crores, 193 crore, 233 crore, 206 crore BOQ items changed, variations. Reasons for change, etc. Contract was selected based on price bid of 135 crore. However, due to location change, BOQ amount was revised to 193 crores, incorporating other changes such as addition of exhibition hall. 3. Amount finalized was 233 crores. BOQ was divided into three parts: pre-construction costs, that is design and preparation of drawings, survey and soil investigation during construction cost, civil works, that is during construction cost, civil works, architectural works, interior, practical rate could be obtained, billing and escalation. Study of billing and escalation included methods, study of contractual clauses, RA attachment, RA format examples, summary, price escalation, study of R&B CPWD method of estimations and related clauses. RA bills were submitted monthly, and in a total 22 RA bills were prepared for phase 1. It was reviewed by professional advisors, random checking as well as PMC, which ensured precision, lesser mistakes and reduced work from being overlooked. PMC was involved with on-site monitoring, but professional advisors was involved with day-to-day coordination. So PMC was involved with on-site monitoring, but professional advisor was involved with day-to-day coordination, which was an added benefit. Breakup was preliminaries 2%, profit 10%, overhead 10%. That is, 1 is preliminaries 2%, 2 is profit, 3 is overhead, and 10% that is for electrical and water charges 3%, and 5 is VAT 5%. I think preliminaries is fine, okay, profit 10%, well, I cannot say it's really less. And overheads 10%, it may be okay, electricity and water charges 3%, well, we are just studying what is content, we'll comment later on. Various billing attachments, material, reconciliation statement, approved drawings as claimed in RA bills, hard copies for BBS, checklists supporting drawings and test certificates, cement consumption statement, something is required, theoretical and practical measurement sheets, all invoices, poor core details having clauses of payment per execution on appropriate pro rata basis against each item, per price paid and no additional amount payment proved to be very much beneficial. This resulted in many savings, as actual execution cost was 206 crore for proposed value of 233 crores. This could be inculcated in future projects for efficient project execution. Price escalation submitted by contractor claimed 950.61 lakhs, but using R&B price escalation formula and working count calculations, professional advisors recommended 474.64 lakhs, which emphasized significance of having an additional monitoring entity. Extension of works analysis. Opinions surveyed and qualitative interview was carried out with client, contractor and professional advisors on these issues to validate and to know level of coordination efforts required to achieve coordination goals for these issues. Key points according to majority were that a great level of efforts was required in coordination activity due to changes which resulted from location change which emphasized the project to be ambitious right from grassroots level. and finalizing requirements before inducting it. Reviewing of issues faced would be beneficial for such future projects. Changes occurring should be controllable. Approval and decision making authority must be speedy. Measure learnings and findings. Measure learning and findings. Through opinion survey, 5 issues which were enlisted, which was validated. Client opined that BOQ process, its methodology, approval process, RA bill, etc., was most critical coordination activity and required highest level of coordination efforts with professional advisor. Opined that design organization, BOQ taking over process and coordination activities is monitoring project performance, identifying potential issues, extra or excess items, etc. Required be highest level of coordination effort. Contractor opined that getting approvals, BOQ taking over processes, and execution activities such as project performance require highest level of coordination effort. Each stakeholder had a role to play, such as client would be primarily concerned with decision making and overall project performance, while professional advisor would act as a liaison between client and contractor and will be more concerned with coordination, and be responsible for all management activities. Contractor was responsible for ensuring project was executed smoothly, keeping in mind all performance parameters. This leads to which marked beginning decision making had and responsible for. Conclusion and recommendations. We have to see what conclusion and recommendations are. This project is an iconic project, time-bound project to be completed within a year, but was completed in fast-track manner within 11 months. A great deal of effort was required in coordination activity due to various issues faced. Significant role of project coordination can be understood from this study. It can be concluded that project coordination is of prime importance and a must for such iconic projects. What are recommendations? Let us see. QCBS method of selection. QCBS method of selection was appropriate, but proportions could have been different. Fewer limitations should be placed on contractor in terms of quality, so that end results are more enhanced. Scope of work should be clearly defined before starting execution. Basic project requirements should be finalized before venturing ahead. This avoids a great number of changes which occur in this project. Even if changes occur, there should be tender clause which prevents issues from transpiring. Clauses which ensure design and variation control should be thought of so. The change is controlled in this project. An additional professional advisor was provided apart from consultants. This ensured the more thorough and efficient implementation of projects. Price escalation must be treated with caution and accordingly must be decided on its incorporation in tender documents. BOQ element was critical, which case in majority of projects, hence the coordination activities pertaining to it must be carried out with precision and care. EPC mode is most suitable for projects where management, where I think this is a reference, design and construction coordination problems and planning for design project new users. These are references, I think, all the references. So it's gone. Okay, no issue. Well, we have understood basics of this, not very important, but I can say close this now. But if we had got this, not very, we can say top level, but all right, it's fine. We can understand if something is good or not. I can say what was last point I missed in that PDF. In learning, and the references are here, and price escalation I was talking of. Let's finish that was left into that. Is that price escalation must be treated with caution and accordingly must be decided on its incorporation in tender document. BOQ element was critical, which case in majority of projects, hence coordination activities pertaining to it must be carried out with precision and care. EPC mode is most suitable for projects where design is complex and new and client either lacks knowledge or time for handling project. So that was one general. Now role of project coordination as a project, and that is this page, and also I think communications, the coordination construction projects, communication coordination, the same coordination number. So I think offline communication coordination. Say, let's see. Just trying to get more information for people in construction product. I think it's very small. Or say, coordination can be seen as a process. This is by Liquid Hossain. Coordination can be seen as a process of managing our resources in an organized manner so that high degree of operational efficiency can be achieved. What's that? The same one, I think. I think it's same one. No, it's not. It's 2008. Why is not full article? I'm sorry, I'm not finding further details on this. That is a problem. These people restrict knowledge. I'm not finding as PDF has gone. Papers, communication, coordination. The same download citation. Let us see what it says. Download citation is. Choose forward. There's nothing in this. No, it's nothing the same, no difference. I'll leave it. Don't waste time. Go, leave it. It's not giving what I wanted. Well, no problem. I am now moving the other one. It's not successful. Coordinating a construction project and emergence of a framework of cooperation. A framework coordination process into construction, 2016. Let's see what it says. Well, I think the same 6 frame of coordination process construction projects. We will like to study this also. It's in PDF format, so first let me download it. Save as coordination in that match, let's say coordination in that. I'll just put it downloaded now. I'm trying to call framework of coordination process to construction projects. Is it something different or that? Okay, it's relatively literally. We'll understand this and do it. Let me first give me 5 minutes. I'll go back. Let me give 5 minutes back and come back. Meanwhile, if you wish to read this, I'll just zoom it. And you can read it. Something you want to read, I'll come and explain to you what we're doing. And that's important point here. Let me do what is that and come back. Okay. Only percent it is 90% available. Charging. Okay. So, so what? So we understand what was done there, it is effective, and we can understand others also. It's only a paper that is having 6 pages, and we can understand it, and if not now, next time, we'll understand it very well. And of course, we still have few minutes only. Let us read by the time something on this. Introduction is construction industry is producer of infrastructures. That's okay. This is in this paper, and this is Wizam S. Elaulol, Muhammad Sharir Lair Noor Amalia Jawabi, Department of Civil Engineering, University. That is, what is this? Let me say it is, correct, Malaysia. What is abstract? Construction industry. Construction industry is recognized as high fragmentation, low efficiency, cost, and time overruns in contrast with other industries. These peculiarities are main roots of poor performance facing by industry. Effective coordination is vital in construction projects. Success and mitigate fragmentation dilemma. However, it is often difficult to achieve and need iterative process. Coordination is core issue to improve performance in construction project. Relevant studies have addressed coordination process, importance, and implementation, but not you can say in a framework. This paper proposes a framework for coordination process in construction projects as well as its interrelationship with performance. Objective of framework is to provide a roadmap for construction parties to realize operational excellence so that collectively stakeholders can recognize effect of coordination process application on project performance. This data obtained from literature review and structured interviews with 5 experts. Analysis produced framework of coordination based on extensively used procedures for information and data flow between stakeholders. So this is just a note. Construction industry is producer of infrastructures and facilities through executing a complex activity and large-scale projects. Differs from manufacturing industry in terms of involving mass production of similar items without a designated purchaser. Uniqueness and fragmented status of construction projects have been significantly affect performance in terms of cost, time, and quality indicators. The relationship between construction industry and economic development is well posted. Construction as vital industry contributes 6 to 10% gross domestic product of developed countries and 3 to 6% to GDP of developing countries. However, construction projects comprise a wide range of activities, including construction, upgrading, repairs, and demolitions. Fragmentation status in project life cycle hinders teamwork, focusing on best interests of project. For example, there is a lot less incentive under traditional approach for contractor to advise on design stage. Interaction among all participants in order to distribute correct information and time is very critical. On the other hand, existence is of significant number of ways which can be avoided minimum. Well, we RAM. Why is it not able to say? What's just behind this, yeah? What's not working here? What's getting open here, isn't it? What's that? Oh, it's out. Just the problem is not working. It is out. Oh, I see. Oh my god, what is this? That is the problem. It's out. Go a long way. It is true. We have to go a long way in this, and we have to understand what is required actually. It's a big deal we have to do with. We have to do with all this, and we have to understand all this. It's also important that we have to understand that it's not easy to get everything done. We need to think of that. In fact. Okay, we'll take up this is already time over, and we'll continue with this next time. I'll something I say I got covered some coordination issues in an excellent way, which relates to petrochemical facility as well as buildings. We just include in today's talk certain references from web, and we'll talk in a collection of all this. Everyday file is getting up and issues, coordinations are limitless. No one limit there, you can say. So we take it for granted now and we close this and take care, which will be back